Method for reading the principal violin mode frequencies by using Audacity software. To learn the frequency of the starting volume, hold the back plate on a point within the nodal region, only in the upper bow. Tap the back plate below the center. Move your fingers within the nodal region if the note you hear is not clear enough. Select a sample, then outline the spectrum. Choose the sample rate and always leave the setting on logarithmic frequency. The frequency peak at 664 Hz corresponds to mode 5. To learn the frequency of the starting volume, hold the top plate on a point within the nodal region, only in the lower bow. Tap the top plate below the center. This mode 5 frequency peak is at 619 Hz. There is 8% moisture content in the wood. When you hold the top plate in the upper bout, you will hear two frequencies quite near each other. When you begin roughing out the starting volume, there is generally a delta of 50 Hz between these two frequency peaks. They can easily be confused when moisture content in the wood is high and unevenly distributed. The reading will be incorrect. To read the frequency of modes 2 and 5 on the intradose, hold the plate by the upper bout. When the mode 2 frequency is not visible due to moisture content in the wood, hold the plate by the lower bout. Mode 2 frequency peak at 163 Hz. Mode 5 frequency peak at 326 Hz. There is 10% moisture content in the wood. Hold the neck by the scroll or heel, then tap the other end. Plot the spectrum and place the cursor on the highest peak corresponding to mode 5 of the free neck at 632 Hz. Hold the fingerboard on a vibrational node at the smaller end and tap on the lower end. Plot the spectrum and place the cursor on the highest peak corresponding to mode 5 of the free fingerboard at 494 Hz. This is the normal method for reading mode frequencies with or without a sound post on a violin in the white or varnished, with or without strings. Position the bass F-hole in front of the microphone. The head of the violin should rest on the thumb. Here you can see a split in the A0 mode frequency with a sound post. B0 mode 282 Hz, C2 mode 396 Hz, B1 minus mode 430 Hz, A1 mode 462 Hz, B1 plus mode 547 Hz. If, due to excess moisture in the wood, it is impossible to read the B1 minus and B1 plus mode frequencies on a violin in the white without a sound post, hold the lower bout by a point within the nodal region. Tap at the level of the heel of the neck. Mode B1 minus 438 Hz. Mode B1 plus 525 Hz. Uneven distribution of moisture throughout the wood perturbs all mode frequencies. To learn the B0 mode frequency without strings, hold the body on a point within the nodal region of the lower bout. Tap the fingerboard by the nut or on the neck at the same level if the strings are in place. The B0 mode frequency peak is always quite visible. Here, its frequency is at 272 Hz. It is preferable to make this frequency reading without the sound post in order to avoid confusion with the A0 mode. In order to learn the mode frequencies of a violin in the white or varnished with strings, insert some flexible material between the strings. Position the bass F-hole in front of the microphone. The tailpiece frequency is 128 Hz. A0 mode, 269 Hz. C2 mode, 397 Hz. B1- mode, 451 Hz. And B1 plus mode, 553 Hz. When the A1 frequency peak is not visible, hold the violin, letting the head rest on your index finger without gripping the neck, and tap the top plate on the bass side. A1 mode frequency peak at 461 Hz. You can make a stand so that the violin will rest on wide rubber bands. The hammer must tap the top of the bridge. Enlarge the window to increase the legibility of the frequency peaks. A0 mode frequency split at 270 Hz. Mode B1-, 446 Hz. Mode B1+, 549 Hz. In general, mode frequency readings made with this method are a few hertz higher than those made by holding the violin in your hand. With moisture content in the materials between 0 and 8%, the mode frequencies are easy to read. The frequencies follow the fluctuations in moisture content between these two levels. When moisture content in the material exceeds 8% and is unevenly distributed throughout the wood, considerable experience is required in order to make accurate mode frequency readings. Several splits will appear on modes A0, B1-, and especially B1+. 3 or 4 frequency peaks may follow each other in close succession, separated by only 15 to 30 Hz.